Hello, folks. I'm really excited today for another Hangar podcast session. Today with us, we have Jack McCloy joining us from Snowflake. Jack, welcome to the Hangar podcast. Why don't you start with a short introduction about yourself?
Yeah, absolutely. Great to be here. Really a fan of what you've been building with the hangar. My name is Jack. I work at Snowflake as an engineering manager. I lead a team called UI Platform, which is responsible for a whole bunch of stuff that deliver value indirectly, horizontal tools that deliver value by helping product teams at Snowflake move faster and build better than they would otherwise be able to do on their own.
Awesome. So, when we were talking about this, you mentioned product engineering infra is how you describe your work, and also something that you've been doing for a few years. This is also a new term I've not heard before. So, maybe you can describe for the audience what do you mean by product engineering infra?
Yeah, absolutely. That was actually a term that I started using 4 or 5 years ago. I was at Amplitude and I built a team called Product Engineering Infrastructure there. And the idea behind it is product teams, the folks that are front end engineers, API level engineers, full stack engineers, in order to move fast and in order to build well, they rely on certain pieces of infrastructure that are unique to their needs. You can kind of like think of Vercel as a product infrastructure company because they provide a lot of that stuff as a service. But inside of companies, there are also projects and in some cases teams that are working on building that infrastructure as well. A couple categories of that infrastructure could be dev environments and build tooling, whatever the bundler is to enable hot module reloading. If you're a front end engineer, that's really important. A design system, the component library portion of a design system that engineers build with would be a key piece of product engineering infrastructure.
That's amazing. And typically in our community, we talk about developer experience as an organization.
Mhm.
And sounds like product engineering is like part of this developer experience organization. Uh, what would you say are things which fall into this bucket versus fall into another bucket which is not product engineering infra? Are there kind of like are these like well defined in organizations, or it's sort of like still have a gray area for responsibilities?
Yeah, I mean, I think that there's a little bit of a gray area. I think that where like a couple of examples of things that clearly are one or the other is tuning a database and sort of ensuring uptime for data pipelines, databases. That's clearly infrastructure, but not product engineering infrastructure. Design systems and the kind of CI/CD process that allows a web app to get deployed super rapidly. That clearly is product engineering infrastructure. There are things that fall on the line. So it's probably less binary and more of a continuum. But the reason why they can tend to be different teams and you want some sort of separation is the skill sets that are kind of needed to do one thing is different than the skill sets to do another thing. A lot of tooling for product engineers is built in TypeScript and sometimes Rust. A lot of tooling for like other parts of infra tends to be built in other languages. So there's a little bit of a separation there.
Okay. So maybe kind of like this goes into the conversation about snowflakes. How is this organization or part of the organization defined internally at Snowflake?
Yeah. So at Snowflake, there are a bunch of people that work on developer experience. for the Java and C++ developers that work on the core Snowflake data warehouse. And that's the real central part of Snowflake's business. On top of the data warehouse, we have products like worksheets and dashboards and things that data engineers, data scientists, Snowflake users use. And that is a Java backend and a TypeScript and React front end. So the tooling to kind of power that application experiences organization and how we think about developer experience, some of it is shared, but a lot of it is pretty separate.
Okay, and how big is your team then?
Yeah, my team is 8 engineers. We own the design system. So there are also a couple of designers and a product manager on the team as well. And we're growing, we're hiring.
That's amazing. And we'll come to hiring towards the end, but share a bit about so how many engineers do you think typically or like your team supports?
Today, we are supporting about 150 engineers across our offices here in the Bay Area, Bellevue, Warsaw, Berlin, and Toronto.
Awesome. So let's get a bit more into the weeds for product, like your work itself. Um, Again, focusing from the perspective of this product engineering or UI infrastructure in some ways, how do you do roadmap planning? And is it like kind of combined with the rest of the developer experience org, or works completely independently?
It is more coupled to the road mapping of the larger application experiences org. So the way that we kind of eh, think about ourselves in the org is we're a horizontal. We talk about like horizontal pillars and vertical pillars, and a vertical pillar would be like a feature team of full stack developers that are building discrete features on top of Snowflake, and we view ourselves as the horizontal team that drives consistency, quality, and shared infrastructure across those vertical teams. So our road mapping is focused on a couple of things. Number one, looking across those different teams and figuring out what are the tooling, the primitives, the things that they need in order to move faster in general, and then also supporting specific asks where it makes sense to.
So share a bit about like how do you measure impact? Are there like KPIs associated with the work within product engineering infra? And I'm also like particularly curious. Dura metrics have become fairly popular. There is also Space Framework, similar lines. Um, is there a correlation of like all of that work with your product engineering infra? Are there certain metrics that are more tied to your work versus the other teams?
I think that, I mean, the Dora metric stuff is great, and it is definitely something that we use and are moving more towards. For the work that we do, we always have a theory of how it delivers value, and we don't always have the luxury of being able to measure that value quantitatively, but we often can move a leading indicator of that value. So, like one example is we measure design system adoption, because we have a theory that when a design system is more well adopted, it has a whole bunch of positive effects around iteration speed, consistency, and quality across the product. And we can measure design system adoption, and it probably is not true that like every tick up of design system adoption yields X dollars of business value, but we do think that it's broadly correlated with us doing more of the right things, more and less of the wrong things. Other stuff that's easy to measure are things like build speed and application performance and rum metrics like that, which we watch very closely. Some of the stuff that's harder to measure is, in terms of value, is around complexity reduction, code quality improvements. How do you measure tech debt over time? And we've got a couple of metrics that we're that I developed at my last in my last role that we're going to be implementing here at Snowflake too, to help with that. It's doable. It's kind of hard though.
Awesome. So I know you have also very strong, strong opinions around tech debt and how this should be handled. So maybe you can share a bit about like high level philosophy of like how, when was the first time you started kind of like thinking about tech debt in which organization, and kind of like how did you come up with some of your thesis around it?
Yeah, I mean, I I don't know. You can't really work in tech at all without hearing people complaining about tech debt, whether it's like a legitimate complaint or not. Like there's the cliche tech debt is code is like code that other people wrote, and there's a certain amount of truth to that because everything feels like tech debt before you ramp on a system. So part of it is like understanding, is something really tech debt, or do people need to just sort of ramp on a system? But tech debt is a real problem, and it manifests in, like, if you've got good developers who are moving more slowly than they otherwise would, or introducing bugs because the system is just very complex and difficult to work with, there's a reasonable chance that tech debt is something that they're fighting with. And I started really thinking deeply about it when I was at a company. I won't name the company, but I was at a company some time ago, and things that were easy in other environments that I worked with, or that I worked at, were just really, really hard to do there. And it started me to think about, hey, like, if an easy thing is hard, how do you prevent it from being hard? How do you recover from it being hard? And how do you keep a system in a state that things don't get harder over time? And that's really what you're trying to do. It's not about like saying all tech debt is bad and you should not have tech debt and you should have teams that work really hard to prevent tech debt. It's less about that. It's more about, how do you keep a code base um, in a place where the next iteration isn't any harder than the last iteration.
That's a very interesting way of thinking about it. So, is there like a formal definition of tech debt? Are there like different categories of tech debt that you think about?
There are, I mean, the way that I think about it is tech debt is the delta between the system that you're working on as it exists today and what you would do if you were building it greenfield from scratch today. And that, like, implies that some tech debt is fundamentally unavoidable, because if you built something 6 years ago using all of the best practices and did it without tech debt 6 years ago, well, best practices change. And by that definition, a code base just sort of um, tech debt increases over time as best practices improve. There's also the tech debt that gets introduced by doing things in a way that is less ideal than you could have, either because you didn't have time to do it the right way, you didn't know the right way to do it. That type of tech debt. And so thinking about it in terms of the delta between where it is today and where you would want it to be is a good starting point. Not being too hard on yourself for tech debt that was unavoidable, but then trying to chart a course from wherever you are to what an ideal greenfield state would be, through getting good at migrations and identifying what those sort of areas that you would do differently are, and then prioritizing them as you can. I think that that's kind of the way that we think about it and talk about it.
I remember when we were at Google, things would like also get deprecated very frequently, and I'm guessing part of it was also around tech debt. There was a funny saying in Google, it's like most of the code is either in beta or it's deprecated. So I think like it was a constant evolution of everything.
Yeah.
So let's say kind of like, somebody joins a company and there is like people complain about tech debt, and maybe they joined as a developer experience or like a product engineering infra person. Is there a way that one can measure tech debt? Or like, I think a better way to think about this is, if you're working on like on improving or creating like a framework to improve developer velocity and reduce tech debt, is there a way for people to see, are things getting better or worse? Like, is there a quantifiable way of doing that?
I think that there are. I don't think that it's sort of like quantifiable in the way that you can give yourself a letter grade or like look at a number and say that's good or that's bad in the way that like a lot of performance metrics, you can say, hey, if the LCP is below 5 seconds, that's fine. If it's above 5 seconds, it's not. Not LCP. If the page load is below this, it's fine. Below, above this, it's not. Um, I think that for quantifying tech debt, some of the things that I like to look at are cyclomatic complexity of code, the total size of a code base as a code base grows, even if the cyclomatic complexity of any function or class or file is in control, the overall complexity of it increases. So figuring out ways to break apart large chunks of code as they before they get too big. Measuring whatever you're doing for static analysis, measuring how often you're muting your type checker or overriding your linter and seeing if those overrides are going up or down relative to the amount of code that's being written. None of these are perfect metrics, but what they all kind of allow you to do is be able to quantify, is like longitudinally measure tech debt and be able to say this is improving over time, or this is getting worse over time, or we're treading water, which is okay because we're moving fast enough, so let's keep doing, like, let's not focus on it, let's focus on feature development, but make sure that we're still treading water here and not getting any worse. Out of date dependencies. One metric that we looked at a lot at my last company was how many out of date dependencies do we have and how far out of date are they, so that we can start to quantify whether that's getting worse or better from quarter to quarter. I think that like everyone knows tech debt exists. Every engineer feels how tech debt makes them slower when it exists, but it's a really difficult thing for leadership to reason about unless you give them some tools to quantify it and say whether it's getting worse or better.
Interesting. There's a lot to unpack there. Maybe one thing to think about is like, let's say as a engineering team, they realize there's so many different dimensions of tech debt, right? We already talked about like, stale dependencies, cyclic dependencies, large code bases. Um, how does one start breaking it down, or in some ways, like, how do you even prioritize among all of this? I would say like debt or like mess, to put it bluntly. How does one start? Like, what do you think would be better places to prioritize to begin improving
Yeah, I mean,
this?
it depends. Like the classic one that I like, one way to do it that I think can be really successful is if you believe that the problem that you're having is the code is complex and engineers are too complex and engineers are introducing bugs or finding it hard to work with because of its complexity, then plot all your files on a 2 by 2, and on one axis have the complexity going from low to high, and on the other axis have the code churn. How many different engineers have edited this file in the past year, or how many times has this file been edited in the past year, and focus on the top right quadrant. The stuff that's super complex but no one's touching, leave that because it's stable, no one's touching it. The stuff that isn't complex, don't worry about that. But the stuff that's super complex that everyone is touching, start there. That's kind of one way to approach it. But I tend to think that with tech debt, it's really two a couple of things matter. One of them is identifying what's really hurting developers most on a day-to-day basis. And to the extent that you can do that, you should start there. But what you want to develop is you want to develop a culture of when people touch things, they make it better. When people make something worse, they know that they're making it worse. And maybe it's a trade-off that's worth making, but at least they understand the trade off that they're making, so that you start to develop a culture where less tech debt gets taken on without eventually being dealt with, or at least if you are taking it on, you're doing it more consciously.
Very cool. So, I mean, you mentioned about code churn and complexity and using that as sort of like a scale or in some ways a compass to um, work on it. Are there like any tools that you have used or would recommend, or maybe all of this has been homegrown? But like, I feel code complexity is such a fairly well complex
Yeah.
topic. Like, how does one even go about building or like thinking about like quantifying code complexity?
Yeah, I mean, I know that there are tools that do that. What I built at Amplitude was hand rolled by my team and I, and we basically measured code complexity the same way that ESLint measures code complexity, and used their logic and just sort of built a CLI around that to identify code complexity. Use the GitHub API to figure out which files were being touched most and identify code churn. We used a library called Madge to identify circular dependencies, which we found were a really high correlate of tech debt and a big blocker to us modularizing our code as much as we wanted to and simplifying it on that dimension. I don't think that it's especially hard to build this tooling in house. I also think that there probably are good third party solutions that you can, or open source libraries that you can use for some of this too. I think the key thing is having a measurement so that you can start to see over time this thing that you care about and believe is important for keeping a code base in a spot where you can iterate on it. Is it getting better or is it getting worse?
Interesting. Okay. And I'll reference some of these things after checking with you for our audience so that if they're thinking about building something internally, they can reference that and read more on it.
Yeah, I guess the one thing that I was lucky at with in terms of Amplitude and Snowflake is both of those companies were analytics companies with like an in-house columnar database. So where do you put that data and how do you chart that data? Like the answer in both cases was super obvious. If I was at a company that wasn't a data company, I would probably pipe it to Snowflake or pipe it to Amplitude or pipe it to Datadog or one of these, like kind of dump the data there so that I can measure it over time.
All right. One other thing we you briefly mentioned that might be worth diving into is convincing leadership, especially when it
Mhm.
comes to tech debt, right? Like there isn't really a very obvious way to present that to leadership, especially when every engineer has a boatload of product features to work on to release on a specific tight timelines. What's your take? Like, what is a good way of actually working with leadership to get these things prioritized? Assuming a lot of tech debt work is not actually done by product engineering organization, but rather it's
Mhm.
a framework which is provided to the rest of the product engineers to work on.
Yeah, I mean, I think it's hard. There's no hack for this. Two things that I would call out. Number one, tech, if you're at a company that's small and pre-product market fit, you probably should not be spending a whole lot of time working on minimizing tech debt. You instead should be spending time working on finding product market fit. So there are places where focusing on this, leadership is right to say, hey, you're focusing on the wrong things. And that feedback is something that you should be I don't know, receptive to. I think that a lot of leaders, they have two concerns when it comes to tech debt projects. One of them is the tech debt really holding us back in a way that's meaningful to the business? And for that one, I find that developer surveys, specific examples of projects that went longer than they should have because tech debt was uncovered that had to be remediated in order for that project to land. That's a really good example of like explaining to leadership, hey, we can keep dealing with this stuff project by project as it comes up, but wouldn't it be great if all of our projects were just faster because we had less of this type of thing to deal with? I think the other concern that a lot of leaders have is they've seen tech debt projects deliver very ambiguous results. So, making sure that you're quantifying how improving on this dimension is going to help projects go faster, and you've got the receipts to back it up, so that so that you're de-risking it from an execution perspective. You're saying, hey, this is the metric that we're going to move, and we're going to move it by this much this quarter, and you're able to then tie it back to increased developer satisfaction, increase developer productivity by being able to say, hey, check it out. People close more linear tickets on the part of the code base that has less tech debt as we measure it. Wouldn't it be great if all of our teams could move this fast? Like leaders, I think, just want to do what's the right thing for the business. And we don't always do a great job of helping them understand how important and impactful and high leverage this type of work can be for the business goals.
Interesting. Yeah, I mean, I've heard from more than one leader in the past around like, refactors barely move the needle. So I think it's always important to kind of like being able to quantify some of these things. I would want to still take like at least a perspective of the other side. Are there situations where one should not like try to improve a tech debt even if it is identified?
I mean, it depends. If it's a heavy lift and it's going to take a lot of work, then you've got to start asking questions like, do we have product market fit yet, or do we just need to race to that? Like, is the business healthy enough that, like, it really comes down to, is the business healthy enough that long-term planning even matters? Because mitigating tech debt is kind of a long-term planning strategy, and that can, like, I would argue at a post product market fit company, or a like company that is clearly working and is struggling to become a generational company, that keeping the code base in a spot where developers can move fast, that they want to work on it, that they don't want to go to other companies, that they don't have to deal with all these problems with, that's can be one of the most important things, but that's not every company. The other thing that I would say is, if you are working on a piece of the code that is very secondary to the business drivers and you're going to retire it in a couple of years anyway, you've got to ask the question, hey, does keeping this evergreen, does making this easier to, does the work that would go into making this part of the code easier to work with even matter? Is that net positive from a business perspective? And like the answer is, I think a lot of times, yes. More times than currently happens, yes. But certainly not all the time, yes.
Awesome. I think we'll just quickly move to the rapid fire round, and
Awesome.
let's cover some of those questions as well. So, start with explaining what are you most excited about, like overall developer experience space in the coming years.
Yeah, honestly, I think that the two things that I'm most excited about in the developer experience space are, one, people are starting to really care about it. Engineers are, in a lot of cases, voting with their feet and choosing to go to companies that use tools that have great developer experience on the margin. And that's pretty cool to see engineers demanding better tools, demanding to be at places that they can do more impactful work because the developer experience is better. And then kind of the corollary to that is it's exciting to see a lot of open source tools and SaaS companies just get caring more about developer experience and empowering that set of developers who care about good tooling to have good tooling. I mean, VS Code today is so much better than what editors were like 10 years ago. The like terminals like Warp and Fig, which was the one that I used until they got acquired by Amazon and got shut down. Like it's wild how good some of this tooling is, and it's an exciting time to be a developer. Like I feel like 10 years ago, the fact that anything worked at all was magic, so we just used it. And now there's just an abundance of great tools to choose from, and that's pretty cool.
Nice. Okay, and you already mentioned a little bit about that Snowflake, your team is hiring. So, what makes a good engineer in the product engineering infra team or like DX team?
Yeah, I mean, I think a lot, half of it is what makes a good engineer in any function. So, like the ability to um, uh, think about problems at different layers of abstraction, the ability to move rapidly, the ability to communicate clearly with stakeholders. Like all of that stuff is important. Specifically on my team, I think what's really important are communication skills. As a horizontal team, we have stakeholders around the organization, and being able to effectively communicate what we're doing and why is really important for all the folks on my team. And then the second thing is systems thinking, just the ability to, I don't know, when you're doing product work, when you're doing work on a feature, the tempo of that work tends to be very iterative, very two steps forward, one step back, like a ship to learn type of approach. When you're building infrastructure, you really can't ship to learn. You have to think through a lot more stuff from first principles because the cost of undo is so much higher. So people who can kind of see around corners in that way and think about how changes in one part of the system, the first and second and third order consequences of those changes, that's really important.
Nice. And what's your take on these AI coding assistants, GitHub Copilot, Codium, those kind of things?
I love them. Think they're cool. It's pretty incredible how quickly they've become part of the workflow of me and other developers on a daily basis. I think they're especially great for like reducing complaints around boilerplate reduction because it you just kind of get your boilerplate written for you as autofill, and it helps you kind of code at the same speed of thought. Where I'm excited for that to move in the future is like Copilot and a lot of the stuff today feels like exceptionally smart and fancy autocomplete. And that's like not a knock. It's a tool I rely on every day. But I'm really excited for the next step where AI agents can be more like thought partners, where you can kind of go back and forth with an agent and iterate to something that's great together by you giving feedback and an agent coming back to you with options and ideas. And I think that we're pretty close to that. I've seen signs of that in a couple of companies already, and more of that, please.
Nice. Very cool. Are there any tools that you recommend that you like?
Oh gosh, yeah, absolutely. I mean, a couple that I'm very excited about right now. I love StackBlitz. One way to think about StackBlitz is if you've used like a remote IDE or a remote editor. StackBlitz is like that without the remote part. If you're like a front end developer or a full stack TypeScript developer, you can use Stackblitz as a remote IDE, except instead of the runtime being on a remote server, it's in a WASM container in your browser. And what's cool about that is it allows you to share the current state of your project with an engineer that you're collaborating with, or a product manager, or reproduce a bug and put it in a pull request and share it with the developer that opened that PR. Stackblitz is incredibly cool.
Interesting. Okay, and last question: are there any books that you recommend?
Tons. I mean, I read a lot. A couple that I would put at the top of my list. Obviously, The Pragmatic Programmer is one that everyone loves. Klepman's book, Designing Data Intensive Applications, is a fantastic one that every programmer, especially every programmer that works at the application layer of the stack, should give a read to. And I don't know, two recommendations for books that are less programmy in nature. I would say Zen and the Art of Motorcycle Maintenance is a great book around kind of like the theory of quality and how you should how you should mentally approach building things and maintaining things. And the Jane Jacobs book, Death and Life of Great American Cities, is just a wonderful book that is about urban planning, but it's really about systems thinking and the sort of how the naive approach in certain situations can very quickly lead to unfortunate side effects and second order effects, and how systems thinking requires you to just dig a little bit deeper if you want to get results that you're happy with.
Amazing. Well, Jack, thank you so much. This was a lot of things packed into a small session. So, really appreciate you sharing all of the wisdom with us. Thank you so much for all the knowledge on tech debt. Have a great day.
Really appreciate it. Great to be on the show. And yeah, thanks so much for having me.